Hi all, so welcome to this video which is replacing the class that we should have had on the 26th of September 2017. So this represents class 15. So due to the 6th-year retreats, we've just had people in and out over the week. So this is basically going to go through the homework first of all that was assigned on the 22nd of September, so that was previous Friday. I'm going to put up the solutions here. I'll go through it quite quickly, but obviously as it's a video, you're going to be able to pause it and do this at your own pace. I'm then going to go through 3 different examples, so please put those into your notes copy underneath class 15. So the first question I'm going to go through was from exercise 11.4, question 7. So the question said there's 3 points. A is minus 3, 1, B is 0, minus 5, and P is x, y. They tell us that the distance from A to P is equal to 3 times the distance from B to P. Prove that x and y satisfy the equation 8x squared plus 8y squared minus 6x plus 92y plus 215 equals 0. So then it asks, say, why this is a circle, and the last question then is find the centre and the radius of this circle. So the first thing we're going to do is we're just going to use substitution, so the distance from A to P and taking P as xy and letting that equal to 3 times the length from B to P, which again taking P as xy. So you can see the workings there. We end up with the square root on both sides. The best thing for us to do is to square both sides to get rid of it. When you do that, so looking from the second to the third line, just make sure, I'll just highlight it here so you can see. Just make sure that you have squared the 3 as well. That's really, really important. So then the next 2 lines are just multiplying out and cleaning up, and you should end up with 8x squared plus 8y squared minus 6x plus 92y plus 215. So that is just as it asked us. The second part then, it says say why it's a circle. So because the answer we got is in the form x squared plus y squared plus 2gx plus 2fy plus c is equal to 0, we can say that it is a circle. Now just be careful, it's not that straight away, because x squared, it only has a coefficient of 1 in the formula. We can force the equation that we have to look like that by dividing everything across by 8. So the last part then says find the centre and the radius of this circle. So the first thing we're going to do is divide across by 8 so we can use that formula. So you can see it there. It's x squared plus y squared minus 6 over 8x plus 92 over 8y plus 215 over 8 equals 0. So then we can pull out our centre. And remember the centre is minus g minus f. So that leaves us 3 over 8 and minus 46 over 8, which can be simplified down 3 over 8, and the y simplifies to minus 23 over 4. And working with the radius, you get 9 root 5 all over 8. So hopefully that question was okay. So the next question I'm going to look at is 11.4 question 8. So again, it's looking something similar to the previous question. A and B are 2 points and there's a point P. So it is such that the length or the distance from A to P is equal to half the distance from B to P. So show that the locus of P is a circle. So we talked about this, okay? We talked about the idea of locus. So it's that sketch that if P was used and a fixed distance was used, that it would create a circle. So what we're going to prove in this case is we're just going to use what they gave us, that we have AP is equal to half BP. So we've done that and we're able to see that actually what it does is it creates a circle, which is x squared plus y squared plus 12x minus 14y minus 5 equals 0. And then it asks us to find the centre and radius of this circle. So using your formula x squared plus y squared plus 2gx plus 2fx plus c equals 0, we're able to pull out the centre, which is minus 6, 7, and we can work out the radius, which is 3 root 10. So question 9. So I think question 9 caused a bit of problems, caused a few problems for people, and it's quite long. So we'll go through it piece by piece. So circle S has this equation here. You can see that it's given us in the form, the H and K form. So x minus 2 squared plus y minus 3 squared is equal to 9. And A and B are the coordinates of 2 points. Show that the x-axis is a tangent to S. Okay, so apologies now, I've put this into the graphing tool and it labeled the center point A and the point on the axis B. However, really, because A and B are already using the question, we should have that called center. So I'm just going to change that here. So this point here is just my center. And this really doesn't represent anything at the moment. So they've asked us to prove that the x-axis is a tangent, which means it's only going to touch it once. So there's a few different ways to do it. So I'll go through the first way, which is given here. So it says it has a center 2, 3, which is what we have here. And it has a radius of 3. So if I drop a line vertically down 3, I should hit the x-axis. And if I do that, I know that the point should be 2, 0. Okay. And when I do that, because it's 2, 0, it is clearly sitting on the x-axis, so that is proving that the x is a tangent to a circle. However, I know some people find these kind of questions tough. How do I know when to do that? So there is a second method that you can use to do that. So I'm going to do that in the space here. So if the x-axis is a tangent to S, then remember it will only cross the x-axis, or will only touch the x-axis once rather than crossing it. So if we want to do something for the x-axis, we're going to let y equal 0. So if we let y equal 0, we get x minus 2 squared plus 0 minus 3 squared is equal to 9. So squaring that out, I get x squared minus 4x plus 4, and this is minus 3 all to be squared, which is plus 9 equals 9. Okay, so you see those two 9s cancel, and I'm at x squared minus 4x plus 4, which actually we just had above, which I know now is x minus 2, x minus 2, and they should both be equal to 0. So I get x equals 2 and x equals 2. So there's only one place where it crosses the x-axis, and that's 2, 0. So because there's only one point, that also proves that the x-axis is a tangent. So that's two different methods we have there that we could have used. So the second part then says, prove that AB is the diameter of S. So be careful. Straight away people will say, well, if it's a diameter, then I can just figure out the length of A to B, and I can say, right, and in this case you can see we worked out that it's 6. From this circle here, we would have had a center 2, 3 and a radius equal to 3. 9 is equal to 3 squared. So notice that they never told us A or B were on the circle. So it's not enough to say that the length from A to B is equal to the diameter. So it must be a diameter, because that's not true. Because imagine this circle here, and imagine here's the point A and here's the point B. Yes, that length is a diameter, but is it actually a representation of the diameter of the circle? Well, no, because it's not on the circle. So if you just did this, great, you've kind of got about half-ish marks. Because you also then need to come along and say, well, is A on the circle? Is B on the circle? Because if they're both on the circle and then the distance between them is equal to twice the radius, then it is a diameter. If they are not on the circle, then it does not represent a diameter. So please make sure that you have these two steps here, that you're able to just show using substitution that A is on the line and then that B is on the line, because it's not enough just to have done the distances in this case. So the third part then, so again we're about this locus of the point. So if a point P, xy moves such that AP is equal to a third of the distance between B and P, show that the locus of P is a circle and label this circle T. So this is just working out like we've done before, again squaring both sides, just pointing out when you're squaring both sides, make sure you're squaring that third as well. And we end up with x squared plus y squared plus 7 over 2x minus 6y plus 7 equals 0. So that's our circle T. So then it asks us to do two things with T. It says find the center and the radius of T. So we can do that using its equation. Remember, the equation is in the form x squared plus y squared plus 2gx plus 2fy plus c equals 0. So we can pull out our minus g minus f quite quickly, and we can work out our radius. The second thing, it says prove that t does not intersect the x-axis. Again, we have a few different ways of doing this. So the start is the same. We're talking about intersection of the x-axis, so we can say let y equal 0. And when we do that, we end up with a quadratic, which we have here. So here's my quadratic. Now, in this case, they've gone and done the discriminant. And they've said, well, since the discriminant is negative, i.e. less than 0, we know that there is no real solution. So it has no real roots, which means it does not cut the x-axis. Alternatively, you can of course go and try and solve, solve using minus b. It won't work with factorization, and you'll find that both your answers give you a big fat error, because that's where the discriminant came from, because you'll have the square root b squared minus 4ac, which will be the square root of minus 63, and when you put that into your calculator, you get an error. And since you won't be able to work out a value for x, any value for x, that means that it does not intersect the x-axis. So if you can remember the discriminant, fantastic, please do. It's very handy without having to do the full minus b. You're just pulling out the b squared minus 4ac part of it. Again, you can be asked discriminant separately, so it is important that you know your discriminant. But if you try to use minus b here, that'd be absolutely fine. The last part then, it asks us to, using the same axis and scale, draw s and t. So we have s here and we have t here. So hopefully it wasn't too bad. Remember from the previous part, you had your center of t, you had your radius, which is all you need to draw it. S, we had both of those at the very start. So then we moved on to a different exercise. It was an exercise 11.5, so it was question 6. So this was about tangents from a point to a given circle. So here we had x squared plus y squared minus 2x minus 2y plus 1 equals 0. And they want to figure out the tangent from the point P, which is 3, 4. So we said the first thing we're going to do is we know that there's a point. So just to remind you, because it might have been a while ago, if that's my circle with my center, imagine this is point P. And it then has two it has two lines that can be tangents, something like this. Okay, so the first thing we're going to do is getting the equation of the line in the form of m, because we don't know what the slope is. And now clearly from the diagram, if you look at those two red lines, there's two different slopes. So we end up with the equation mx minus y plus 4 minus 3m equals 0. So we're using the formula y minus y1 is equal to m bracket x minus x1, where we know the point 3, 4 is definitely on the line. The second thing we want then is the radius, because I know, I'm going to switch colors again, I know the distance from my center point to a tangent, so the perpendicular distance, is going to be equal to the radius. So I know these green lines both now represent 1. So we use the formula, we use the fact that the circle equation was giving x squared plus y squared plus 2 gx plus 2fy plus equals 0, and we've been able to work out the radius and its center. So we now know that the radius is 1 and the center is 1, 1. So now I use the perpendicular distance formula to measure the distance from 1, 1 to the red lines. But obviously the equation of the red lines are in m. So I have to let that distance equal 1, which is happening up here. And then I work through it. So on this line here, you'll have a square root and an absolute value sign, or your modulus lines. So squaring here is the best option. When you square a square root, it disappears, okay? Because you're squaring a square root. When you square the absolute value lines, yes, the absolute value lines disappear, but you still need to square. Okay, so you end up with that bracket squared. So just be careful on that. And then when you work all that out, we should get two values for m, which are 2 plus or minus 2 root 3 over 3. And you can sub that in. If you did that in decimal form, that's absolutely fine as well. They didn't indicate to us that you had to leave it in third form. So once you have your m, if you got that far, please make sure you do go back and sub in both m's to get your two separate equations. Because remember, that's the question. Find the equations of the tangents. It's not about getting the slope. So although a short question, when it's asked, it actually has quite a lot of working to it. So the second part of 6 then, very similar question. So we have an equation here and it said find the tangents from the point P. So again, from the point, so P is not on the circle. We looked at examples of when they wanted us to find the tangent of a point on the circle, and that's asked in a slightly different way. So this is asking again for a point that's not on the circle, so we're going to end up with two different equations of tangents. So we can pull out our center and our radius from our of our circle equation given, and that we get center -1 -4 and radius 3. We let the slope of the tangents equal m, and then we create an equation which is mx minus y minus 6m minus 1 equals 0, because we know that the point P, 6 minus 1, is on that line. So we're able to sub that in. So then we use our perpendicular distance formula to say that the distance from the center point, -1 -4, to the line, which is a tangent, which is mx minus y minus 6m minus 1, that should all be equal to 3. So we have it set up there. Again, just watch your squaring. If I just jump up to the top of the second box here, when we square that 3, we end up with 9. When I square the square root, it just cancels out. And when I square this absolute value signs, it actually has to be fully squared out. So just be careful. And we work out with two values for our m. So we get m is equal to 0 and m is equal to 21/20. So we end up with two different equations. So the first one is y minus 1. So that's the first equation. And then the second one is 21x minus 20y minus 146 equals 0. So then we had question 8. And this was asking about circles touching externally. And this becomes really important as we get into the exam questions. So it says sketch the two circles and prove that they touch externally. So if they touched externally, what we said was we know that if I add, sorry, let me change color here. If I add this radius, the bigger radius, to the smaller radius, it should equal the distance between their centers. And that's exactly what we're going to do. The first thing we're going to work out is the distance between their centers. And when we do that, so this piece here, we find that the distance between their centers is 5. My two circles, the first one has a radius of 4 and the second one is 1. And since 4 plus 1 equals 5, the circles touch externally. So it's quite a nice question, but it's just to remember that. We also need to know about them touching internally and if they overlap or if they don't touch. So they're kind of our 4 scenarios that we need to know. So let's move on to kind of the new examples that we're going to look at today. So it's finding the equation of a circle without a center point and radius length. So if you look in your log tables on page 19, there's a little section. So the second half of page 19 is base for the circle. So its formula is the circle, and it says given this center HK and given the radius R, here's how you build a circle. In the second one, it's again, here's an equation and you can pull out the center and the radius. So what happens if we want to get the equation but we don't know a center point or a radius length? So in this case, we use the second formula, which is x squared plus y squared plus 2gx plus 2fy plus c equals 0. And we take our center as minus g minus f, so we leave that as it is, and we create simultaneous equations. Now, please be aware the simultaneous equations mean that there will be multiple equations where we have to work together to solve for an unknown. This does not necessarily mean we'll be using the elimination method in all cases, because there are several different methods for solving simultaneous equations. So remember that when we talk about simultaneous equations, it just means that there's multiple equations. So if you look here, we'll have a G, an F, and a C in most cases. So we'll be looking at 3 equations in most cases because we have 3 unknowns. So one unknown, it only takes 1 equation to solve it. 2 unknowns, we take 2 equations. 3 unknowns, we need 3 equations. So let's take a look. So here's example 1, and this is where we're given 3 points. So I've taken this from 11.6 and it's just question 1. So let's work through it. Find the equation of the circle which passes through the points A, B, and C. So what we start with is we start with our equation of a circle formula. So it's plus 2gx plus 2fy plus c equals 0. So I'm going to take the point A and I'm going to make my first equation. So I'm going to say, well, it's 1 squared plus 2 squared plus 2g by 1 plus 2f by 2 plus c equals 0. So when I do that, I find that I get 1 plus 4 plus 2g plus 4f plus c equals 0, which gives me, which gives me 5 plus 2g plus 4f plus c equals 0. And that's our first equation. So now let's look at the second one. So it's where b is 4 minus 3. So for b then, it works out as 4 squared plus minus 3 squared plus 2g times 4 plus 2f times minus 3 plus c equals 0. 16 plus 9, remember any number squared is positive, plus 8g minus 6f plus c equals 0. And this gives me 25 plus 8g minus 6f plus c equals 0. And that's equation 2. And then c, which is 0 minus 2. And when we sub that in, we get 0 squared plus minus 2 squared plus 2g0 plus 2f by minus 2 plus c equals 0. So when I clean that up, 0 squared is obviously 0. We get minus 2 squared is 4. 2g by 0 is 0. So I get minus 4f plus c equals 0. Okay, and that becomes equation 3. Okay, so now you need to work with these 3 equations. Basically, if you can remember back last year to your algebra where we had systems of 3 equations with 3 unknowns, we picked 2 equations, worked with them and eliminated 1 letter. Then we worked with 2 different equations and eliminated the same letter. Now, we always said make sure you look and see how to make your life as easy as possible. And if you notice, the last equation is missing a g. So if we could get rid of g from 1 and 2, we'd be able to work straight away with our answer with 3. So let's look at that. So 1 is going to be 5 plus 2g plus 4f plus c equals 0. And then equation 2 is going to be 25 plus 8g minus 6f plus c equals 0. So to do all this, I'm going to multiply the top line by minus 4. So we have some elimination going on. So I get minus 20 minus 8g minus 16f minus 4c equals 0. The second line stays the same. Minus 6f plus c equals 0. And when I do that, my 8g's cancel and I'm left with 5. And I get minus 22f minus 3c equals 0. So this becomes equation 4. So now I take equation 4 and I work it with equation 3. Because now they both just have an f and a c. So I get 4 minus 4f plus c equals 0. Easiest thing to get rid of here is the c. So let's multiply the bottom line by 3. So I get 5 minus 22f minus 3c equals 0. 12 minus 12f plus 3c equals 0. And the c's cancel out. So what I get is 17 minus 34f equals 0. So when I work that, I get minus 34f is equal to minus 17. So f is equal to a half, or 0.5. So that's one of my values. I then want to go back and sub it back in. So let's take a look. So I'm just going to clear the left hand side here, just so I have some more room to work with instead of moving to another slide. So let's get rid of this for a second. Okay, so now that we have our value for f, which is a half, I'm going to sub it back into either 1, 2, or 3. Now, obviously, because we want to figure out another letter straight away, our best bet is to put it into 3 because that will straight away then give us c. So 3, if you remember, is 4 minus 4f plus c equals 0. So let's sub in. I now know that's 4 minus 4 by a half plus c equals 0. So that's 4 minus 2 plus c equals 0. Excuse me. 2 plus c equals 0, so c equals minus 2. So that's our second one. And then we can go back to either 1 or 2. I'm going to take 1. It's 5 plus 2g plus 4f plus c equals 0. And I'm going to sub in for my c, 2g, and my f, plus 4 times a half, plus minus 2 equals 0. Let's clean that up. 5 plus 2g plus 2 minus 2 equals 0. So 2g equals 5. Sorry, minus 5. So our plus 2 and our minus 2 cancels out here. So g is equal to minus 5 over 2, or 2.5. Like we've done before, it's a good idea to highlight your letters that you found. However, unlike algebra, this is not where we finish, because the question asked us find the equation of the circle. So what we need to do is we need to sub that back in. So we have x squared plus y squared plus, now it's twice twice gx. So it's going to be twice by minus 5 over 2. So twice by minus 5 over 2 x plus 2 times f, which is a half, y, plus c, which is minus 2, equals 0. So let's clean that up. I'm just going to put it up the top. So we get x squared plus y squared minus, be careful, 5x plus y minus 2 equals 0. And that's our final answer. So unlike when we had systems of simultaneous equations in algebra and we just finished with our 3 numbers, this requires us to do a little bit more and to go back and fill it in. So example 2. Find the equation of the circle that contains the 2.00 P42 and whose center is on the line x plus y equals 3. Okay, so slightly different, but we do know that I can sub in the point 0, 0, and it should work. So, and we know that we should be able to sub in the point P42 into the equation of a circle. Remember, we're taking the equation of the circle as x squared plus y squared plus 2gx plus 2fy plus c equals 0. So here we have 0 squared plus 0 squared plus 2 times g times 0 plus 2 times f times 0 plus c equals 0. Everything will cancel out, leaving us with c equals 0. Okay, so that's a really important, this is really important for us to know because we can sub that back straight away. So we have 4, 2, so let's sub that in. So we have 4 squared plus 2 squared plus 2g by 4 plus 2f by 2 plus 0 equals 0. So I don't need to put in that c. So I get 16 plus 4 plus 8g plus 4f equals 0. So I get 20 plus 8g plus 4f equals 0. Okay, so that's kind of my first proper equation. I know we could argue that we got an equation for the first part, but really we just got an answer for one of our unknowns. So obviously we don't have enough information. We have two unknowns, so I can't solve it with that one equation. So we have to look at the second piece of information that they gave us in the questions. They gave us there's 2 points, and then they said the center of the circle is on the line x plus y equals 3. So in this form, the center is minus g minus f. So I know that minus g minus f is on the line x plus y equals 3. So if I sub that in, it should work. So I get minus g minus f equals 0. Okay, and sorry, it does not equal 0, it actually equals 3. Apologies. So it equals 3. So we're just subbing into this equation here. So that gives us our second equation in a f and g. And we can now do simultaneous equations elimination on them. So let's take a look. We have, and I'm just going to rearrange this slightly, 8g plus 4f equals minus 20. And then I get minus g minus f equals 3. Easiest thing to do to get everything to get the f's to eliminate is multiply by 4. So I get 8g plus 4f equals minus 20. So I get minus 4g minus 4f equals 12. Here they cancel and we're left with 4g equals minus 8, so g is equal to minus 2. So once I know my g, I can go back to equation 1, and equation 1 is 20 plus 8g plus 4f equals 0, and I get 20 plus 8 times minus 2 plus 4f equals 0, so 20 minus 16 plus 4f equals 0, so 4 plus 4f equals 0, so f will work out to be minus 1 as you do that. Now, if you notice that for the equation 1, you could have simplified this and you could have broken it down and divided the whole way across by 4, which would give us 5 plus 2g plus f equals 0, and that's absolutely fine. If you want to do that, then that will all work away. And if you did that, then you wouldn't have to have done the multiply by 4, but both methods will give you, or should at least give you, the same answer. So then if we go and finish it off, we want to sub those two values. So let's highlight those two values. So we got g is minus 2 and f is minus 1. So let's put that back into our equation. So we get x squared plus y squared. So we'll end up with minus 4x. So we're subbing in 2 times minus 2. And 2 times minus 1 will give us minus 2y. And c is plus 0. So you can ignore that. So we can have x squared plus y squared minus 4x minus 2y equals 0. So that's the equation of the circle. So again, simultaneous equations, and this time just 2, but we had to get that third piece of information from the fact that we knew that the center stayed on a given line. If we hadn't got a C straight off, so like we did here, you would have had to use the first equations, the equation from the first point and the equation from the second point, and you would have had to work with them to eliminate the C, because there's clearly going to be no C in that third equation. But again, it would have been very similar to ones you've seen where there are systems of simultaneous equations with 3 unknowns. So we've seen examples of that before. So the last example I'm going to do is where we have 2 points and then they talk about a tangent. So find the equation of this circle which passes through the point P and Q and has the line this as a tangent at the point minus 3 minus 2. Now you might get excited and say, oh, but they've given us a third point. Well, they haven't, because that point P is one of the points that they've already given us. So let's take a look at this. So just like before, we know that the point P is on the circle, sorry, minus 3 minus 2. So if we sub that in, and again, I'll put this up here, x squared plus y squared plus, it's 2gx plus 2fx plus c is equal to 0. So we get minus 3 squared plus minus 2 squared plus 2g times minus 3 plus 2f times minus 2 plus c is equal to 0. This gives me 9 plus 4 minus 6g minus 4f plus c equals 0. So 13 minus 6g minus 4f plus c equals 0. Q then is 0 minus 1, so we can sub that in. So we get 0 squared plus minus 1 squared plus 2g times 0 plus 2f times minus 1 plus c is equal to 0. Here anything, so 0 squared is 0, so 1 squared is 1, plus 2g by 0 is 0, minus 2f plus c equals 0. So we have equation 1 here, we have equation 2 here. So again, now we have a lot of unknowns going on, but we don't necessarily have all the information that we need, because we won't be able to solve this using just two equations, because if you notice we have a g, an f and a c. So to go back and ask what's the extra piece of information that they gave us, and it said the line 2x minus y plus 4 equals 0 is a tangent, and it's a tangent at the point P. So the last piece of information then, how we can use that is, if you remember, and I'm going to sketch it out here, if I have a circle and I have a radius, I know that the point from the center to the tangent, is going to be perpendicular to the tangent itself. So let's take a look at the tangent. I have 2x minus y plus 4 is equal to 0. So the slope of that line can be found by rearranging in the form y is equal to mx plus c. So we get y is equal to 2x plus 4. Therefore, my slope is equal to 2. So that's really important. So we just got the slope of the tangent is 2. Therefore, the slope from the point, from the center point, which we don't know, but we're going to say is minus g minus f. The slope of that to the point at the tangent, so minus 3 minus 2, the slope of that should be the perpendicular slope here. So if the first slope m is equal to 2, then the perpendicular slope is the opposite reciprocal, which means we flip it and we change the sign, which is minus a half. So when I do that slope, I'll do y minus y1, so I'll have y2 minus y1, so plus f all over minus 3 plus g, and that should give me minus a half. So rearranging that, I get 2 times minus 2 plus f is equal to minus 1 minus 3 plus g, minus 4 plus 2f equals 3 minus g, and finally what I will get is 2f plus g equals 7, and that gives us our third equation. So that's our 3 equations there. So now we have 3 equations, so let's do simultaneous equations. So we have 13 minus 6g minus 4f plus c equals 0. The second one we had 1 minus 2f plus c equals 0, and the third one was 2f plus g equals 7. So now it's not a standard elimination type of simultaneous equations, because we have 3 unknowns, but each of the equations have a different set of unknowns. So the best way for us to deal with this is actually using isolation and substitution. So taking equation 3, I can rearrange that to be g is equal to 7 minus 2f. I'm then going to sub that into 1. So instead of g, I'm going to do minus 6 by 7 minus 2f. Minus 4f plus c equals 0, so I get 13 minus 42 plus 12f minus 4f plus c equals 0. Now, so minus 29 plus 8f plus c equals 0, and that actually gives us our fourth equation. So now I can work with equation 2 and equation 4 because they both have the same two unknowns. So I have 1 minus 2f plus c equals 0, minus 29 plus 8f plus c equals 0. And here I can change the signs. Plus, this becomes a minus, and this becomes a minus. And when I do that, the c's will cancel. So what I end up here is 30 minus 10, f equals 0, so f will end up being 3. Okay, so I've just skipped some steps there. But when you bring the 30 across the equals, it becomes minus 30. Divide both sides by minus 10, and you get f equals 3. So then, in order to find our c, let's go back to equation 2. So equation 2 is 1 minus 2f plus c equals 0. So 1 minus 2 times 3 plus c equals 0. 1 minus 6 plus c equals 0. Minus 5 plus c equals 0. So c equals 5. So that's our second. And we'll go to the third equation then, subbing in for f to work out our g. So 6 plus g equals 7. G is equal to minus 6, so g is equal to 1. So our three variables, or our three unknowns in this case, f is 3, c is 5, and g is 1. So if we go back to the equation of the circle formula, it's 2gx is 2fy plus c equals 0, and we sub in x squared plus y squared plus 2 times 1x plus 2 times 3y plus 5 equals 0. So we get x squared plus y squared plus 2x plus 6y plus 5 equals 0. And that's our equation of the circular formula that we've been asked for. Okay, so just again, three examples, all creating the equation of a circle, but instead of using the traditional center and radius method. Okay, please make sure all of these have gone into your notes copy, and this again is finishing off the circle section in the book. So from here we're moving into our exam questions on both the circle and the line.